Commercialization in calculus. Calculus, we have seen all your aspects. So calculus, we have seen all your aspects. So commercialization in calculus. Commercialization in calculus, which part? Calculus has many parts. If you see mathematics, then it has kind of, if I see mathematics, then it is kind of numeric and then algebraic and then numeric, algebraic, and then we have vector, calculus, and then different coordinate system. Okay, which part would take it to commercialization? That is vector. Vector is a kind of a technology that is the technology that talks about direction. So direction may lead you to future. Okay, if I say x-axis, then I say this is origin and this is x-axis. Algebra. This is origin and this is x-axis. This is origin and this is z-axis. This is origin, this is y-axis. If someone talks about x-axis, what he talks? X-axis is a line, y-axis is a line, z-axis is a line. It never talks about direction. That is the catch here. It never talks about direction. So, if this is the origin and this is the line, then line can be in this direction, in this direction. So, when it comes to vector, then it is no more x-axis. It is I unit vector. If it is this, then it is j unit vector. If this is this, then it is k unit vector. If I represent x-axis, y-axis, and z-axis as vector, then it is I, j, and k. Or if I say I, j, and k, then it is vectorization of the axes. Positive x-axis, negative x-axis, not required. I vector minus I vector, j vector minus j vector, k vector minus k vector. This is vectorization. So we will proceed in vectorization. If I have anything, can I do vectorization? What is vectorization? Consider I have a circle. This is a circle. How I can do vectorization of this circle? If I take any point here, if the circle is centered at the origin, if I take any point here, consider this point is P. Then from center, if I draw a line through P, okay, then this is called position vector. If coordinate of this P is x comma y, then if I draw a position vector, this is xi plus yj. This position vector keep rotating. Okay, this position vector keep rotating. This way I can describe the circle. Circle equation is y equal to square root of a square minus x square, where a is the radius of circle. If I talk about position vector, then it is xi plus yj. It is xi plus square root of a square minus x square j. This is one kind of vectorization through position vector I can see. If I keep changing x, position vector would keep changing like this. There is another guy, if this is the point x comma y, then from origin if I draw a line, it becomes xi plus yj. But not only that, if at this point, if I touch this point, if I touch this is also called tangent, then this touch line also represents the circle. Okay, this is called the gradient vector that also represents the circle. Which one we want? That is the concept. Which vector we want? Anyway, okay. So this is termed as vector field. Vector field, vector field. I have algebraic equation of a circle. If I have algebraic equation of a circle, and that circle, if I represent it through vector, either position vector or gradient vector, that is termed as vector field. That is termed as vector field. What is vector field? Vector field is a vector which every vector has a component, right? So vector field is a vector whose component is algebraic equation. Like vector field of this position vector is xi plus square root of a square minus x square j, where x component is x and j or I component is x and j component is the square root of a square minus x square. This is position vector of a circle. This is a vector field. Or if I go with the kind of differentiation, if I calculate the gradient of this, then this becomes I plus minus x divided by square root of a square minus x square j. This is also a vector. This is also a vector. That vector is this vector, tangential vector. Okay. I plus minus xy divided by a square minus x square. If x is a, if x is a, then I component, x component is 1 only, but the y component becomes infinite. In that case, it is, if it is this x-axis I vector, then at this point it is exactly perfect towards the y-axis. Okay, so a vector field is a vector with components whose components are algebraic equation. Vector field. Okay, if I have a position vector, I can calculate the gradient of this position vector. We have seen lot of enjoyment, right? If I have a vector field of a position vector, then I can calculate the gradient, that becomes velocity vector. I can calculate the magnitude, and if I integrate, I get the curve length. Vector, you are amazing. Means no way, no one can calculate the curve length. But if I represent it as position vector and do the gradient, then it becomes velocity vector. And in the velocity vector, if I calculate the magnitude of the velocity vector and if I do the integral, it gives me the curve length, because velocity vector is along the curve. And if I calculate the magnitude and integral, it brings back to displacement, and displacement becomes the length of the arc. Vector, you are amazing. Vector is something that we can call it algebra plus plus. I won't say calculus plus plus, because calculus works only on algebra. Calculus works only on algebra. Calculus does not know direction. Calculus is blindfolded. Okay, like algebra works on numeric science. Algebra is nothing but variable numeric science. If numeric is variable, it is changing, then we come to algebra. Okay, if algebra, if I want direction, then it comes to vector. Okay, and then vector, if it is in different orthogonality concept, a vector has orthogonal components. Okay, those orthogonal components can be Cartesian, can be polar, can be cylindrical, or it can be spherical. So this is vector plus plus, that is Cartesian coordinate system, or vector inherently, internally vector is represented through orthogonal components. These orthogonal components can be any coordinate system, but that component can be numeric or it can be algebraic. If it is algebraic, then it is vector field. Okay, and then calculus. Calculus sits on algebra. Calculus do not know your spherical coordinate system. Calculus do not know your numeric algorithm. Calculus do not know your vector. Calculus only knows algebra. Calculus calculates the area of a algebraic function. That's it. So calculus has nothing to do with anyone else. I say I have a numeric that is 5. Then calculus will understand 5 into x to the power 0. That is the algebraic equation. But anyway, can we do calculus on vector field? Calculus do not know vector, but vector knows algebra. Understandable, right? So if this is algebra, then calculus is here completely dependent upon algebra. This is vector field which is using the algebra. From vector field, I do all the manipulation in the world and finally brings to an algebra on top of which I can apply calculus. So if this algebraic equation, what I get through the, because vector field, it is going to bring an algebra only, where vector field has direction. Direction is very important. If someone is saying that how, what is your speed, then the speed is 100 kilometer per hour. It is very high speed, 100 kilometer per hour. That's it. But someone talks that 100 kilometer per hour in the direction of moon, means he is going towards space. In few minutes only he will be out of the oxygen. If someone say 100 kilometer per hour towards the earth, then just think that what will be collision post experience. But 100 kilometer per hour on the earth, then it is going in 2D direction. So direction is important. So algebra is variable numeric. A numeric which is variable, then it becomes algebra. When algebra has direction, then it becomes vector. Vector has components. Vector has components. These components are algebraic functions. But this component, the I vector, J vector, K vector, what we call it, if that orthogonal component, direction of the orthogonal component, this is better word. If I have a vector field and it has components, you can say first component, second component, third component. First component, its magnitude is determined by the algebraic equation, but direction, that is determined, can be determined by Cartesian coordinate system, polar coordinate system, cylindrical coordinate system, a spherical coordinate system. But calculus always sit upon the algebra. Calculus does not know your different coordinate system. Calculus do not know your vector field, and calculus do not know your numeric science. It also knows algebra. So whatever the scenario I am trying to present through Cartesian coordinates, through coordinate system, through vector field, or through the numeric science, if you want, if you know whatever you are doing, it is rate of collection. From you need the collection, for that you need integral calculus. If you have the collection, from collection, if you want rate of collection, then you need differential calculus. So integral calculus, differential calculus. But calculus need algebra. Calculus do not need, like elephant needs the plant, the tree leaf. That's it what he eats. And then lion what it eats. So everyone has a fixed food. So for calculus, food is algebra. But algebra can be embedded inside a vector. A coordinate system can be embedded inside a vector. A numeric system can be embedded inside a vector. Then it is a static vector. Vector is a big guy because it talks about direction that no one can give. Coordinate system cannot give the direction, x-axis, y-axis, z-axis. Calculus is from rate of collection to collection, collection to rate of collection. This is what calculus would do. Numeric science, no direction, 10, 20, 30. Algebra, x square, y square, z square, whatever it is. Vector uses coordinate system. Vector does not do anything with calculus. Vector uses coordinate system. Vector uses algebra. Vector uses numeric science, and vector then produces something That is direction specific, magnitude specific. Vector, you are amazing. You are very auspicious. Okay, so we will do many things in vector. We are not hiding anywhere. We are not that we ended up with the calculus and we will not do anything with the vector. We will do with the vector. Okay, so if I have a vector field is represented as capital F. A function is represented with small f, whereas a vector field is represented with capital F. Capital F equal to F1, first component, I can say I, plus F2 J, plus F3 K, F1, F2, F3. If they are numeric, it is a static vector. If F1, F2, F3 are algebraic, then it becomes a vector field. Okay, ijk, if it is ijk, then it is Cartesian coordinate. But if it is in r and theta, then it is polar coordinate. If it is in r theta z, then it is cylindrical coordinate. If it is r theta and phi, then it is a spherical coordinate. So algebra keeps everything. But if you want calculus in algebra, you can do component by component. F1, which is algebraic equation, you can do calculus on top because calculus did algebra. Okay. So if I have a vector field, I can calculate the gradient of this vector. So this much I can do. Have you ever thought about flowing water which is flowing? Okay, so this is a this is flowing water. This is flowing water. So this is flowing water means this is river surface. This is river surface and river is flowing from this direction to this direction. Now I kept a boat. This is boat. Okay, I kept a boat and kept on the river. Okay, boat is silently moving. This proves that there is a work done by the river. If boat is displaced from one location to other location, when river water is moving, then there is a work done by the river. How much work is done by the river from one point to other point? That is the question. This proves that work done is, if there is a displacement and if you want to calculate the work done, there has to be a force. Force into displacement is work done. So how much work done by the river if this much displacement happens? Then you have to know what is the force of the river. Many people say this river has lot of current. This river has lot of current. Okay, current means how much force it has. So force into displacement is that much work done by the river. Force is a vector which has a direction. Displacement is a vector which has a direction. Okay, if I keep this boat here and as per the river it moves like this, I don't want this. I want to cross the river rather than river. If I keep something here, if I keep a boat here, I'm expecting that boat will go this side to that side. Okay, what is work done by the river? Zero, because I don't want to go along the river. I kept the boat along the river side and boat should go other side of the river. This is why what I call as work done. What is work done by the river? Zero, because the displacement what I am expecting is from this direction to this direction, whereas force has this direction. So work done is nothing but force dot product of displacement vector. Force vector dot product with the displacement vector. So if force vector is along x-axis I vector and displacement what we are expecting that is along j vector, then force is whatever it is I dot our displacement is j unit vector 0. no work done. But someone is saying, how come work did not happen? Work done. See, went to this side to that side. Boat went from this side to that side. No, I don't want that. I want boat to go from this side to that. Then only I'll call it work done. So displacement, what I am expecting is J, and the force is in I vector. I dot J, then whatever work done I am expecting from the river, it is not happening. Okay. So if someone is crossing the river, okay, and he is applying the force, if he is applying the force, then how much displacement would happen when river is applying force in this direction? Is it same as I am applying same force when I am going in the still water? So that's why I say commercial calculus. When vector comes into the picture, it becomes commercial calculus, because now you will calculate in dollar that how much I need to pay for this and that and those things. It can come to share market. It can come to any kind of, you are selling a car, motorbike, or whatever it is. So it will come to those markets. So this kind of the vectorization gives the direction. So if you are expecting your money, like if you are making people cross the river on a boat, and this is how you will earn money, then if river is flowing in 90-degree, then certainly river is not helping you to earn the money. Okay. What about if 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 river is flowing and I'm taking a boat, okay, and boat in the river, boat starts spinning little bit, and then I have a machine in the boat, and I push the boat along. Boat is coming and it is whirling, whatever it is, and then it is proceeding forward because I have proceeded. Can I know that this river had a, I mean, this is how I am earning money. This is how I am earning money. I am taking people to the river, and then I am pushing the boat through machine, and I am taking the boat at the center of the river. Then it makes two turn like this, and then I proceed forward. Okay, through machine I make it rotated. Can I know that how much river would assist me? If river, suppose that I don't want to pay any money as far as rotation is concerned. For rotation, I need to purchase different kind of machinery in the boat. So one machinery is taking boat from this side to that side where river is flowing this side to this side. Okay, and if I take this boat at the center, suddenly boat starts rotating. I don't know. Then I take the boat this side. For this I am charging people. People, they are thrilled when they go at the center of the river. Slowly it starts rotating. When it rotates two times, then I take it. How much river would help me in the rotation? One question. Other question is, I am taking this boat at the center, and then boat moves along the river. For this is the design. This is the design that I am telling the people. Come, and I will take you to from boat, and from this side I'll go at the center of river, and then we will move 100 meter in the right direction. Then we will go to the shore, that direction. People are thrilled. Okay, so I will go like this, and at the center, and then I'll move 100 meter, and then I'll go in this direction. When I go in the center, I switch off the motor. And then river takes me 100 meter this direction, and then I go this side. Okay, whatever I'm trying to get from the river, how much river helps me? If I say my boat is going at the center, and then it is going along the river, and then I'm taking it to shore, when it is moving along the river, then I don't need to use the motor. in the boat because river is helping me. Or if I take this at the center and then river rotates it two times, this is what the design is, and then I go to the shore, then I need not purchase any machinery which rotates, it saves. How I know that river can rotate my boat? This is called circulation density. This is called circulation density. Okay, so probably we will talk more on the circulation density. It is also called it's curling, right? My hand is river. My hand is river, and if this unit comes in the river, river starts rotating it. How I know that river will start rotating it? That is the question. How I know that river will start rotating it? If my hand is river, if my hand is river, and in my hand, if this entity comes in my hand, as soon as it comes, it starts rotating. This proves that my hand has rotation capability. This is also called circulation density. How I know that river has rotation capability? If river, if I want rotation capability, what is required? That is called flux. That is called circulation density. Flux, circulation density. We will talk, I'm sorry, not flux, curl. Curl, we'll talk about flux also. These are all feature of vector field. So we will talk about flux also. So this is curling. So if my hand is river and when it comes in my hand, it starts rotating. My hand has curl tendency. If river boat is going inside river and it starts rotating it, then river has curl property. This is also how I can measure the curl property. This measurement is called circulation density. Many times circulation density would be unwanted. If I know this river has high circulation density, certainly I would not like to enter into the river. God knows where the whirlpool will start. If someone is swimming in the river and any moment whirlpool starts because it has curl tendency. That's why I say commercial calculus. So if it has curl tendency, how we can measure the curl tendency, circular density of a river? If it has high curl density, then any moment it will start rotating. And person will start remembering God. Okay, so this river has no circulation density, zero. You can swim. But this river looks very smooth, very calm, very peaceful, but it has high circulation density. Any moment whirlpool will start. Okay, so how we can measure these things and where from these sciences came into the picture that river has circulation density. This is curling. We will talk many things. If you remember, earlier we talked about Green's theorem. Green's theorem. Green's theorem and path independency in the vectorization. So those things we will talk.